of the Marshall 1987X mod series. Part 1, we looked at the stock amp. Part 2, I had, kind of roughed in the main changes that I was planning to do, and, just kind of ran through some basic tones there. Part 3, here we are, the amp is finished, right? So what we have done to this thing basically is convert the 4-hole, plexi 50 watt amp into the bones of a 2204 JCM 800, but with some tweaks to kind of hot rod that. I've also put our FET boost board in the fronting of the amp. I often get asked about what our FET boost is all about. It's a high voltage gain stage, right, but using a transistor, a MOSFET transistor. So that actually sits at the front end. So you can kind of think of that like a high voltage clean boost sitting as the first gain stage. It's foot switchable as well. So we will run through that. I've also put a couple of different Jose clipping options in on this, and I've tried something different on this one, which I'm pretty happy with how it's worked out, and I think it might feature in a few more mods, or even some of my standard amps, to be honest. So what it actually does, it allows the classic Jose style clipping, but keeps the master volume in its traditional spot, which just makes it a bit easier to work with effects loops and so on. So what I thought I'd do is we'll run through some basic tones. So here I've got the amp dialed in pretty much at midday on the front here, so presence, bass, middle, treble. I've got the master volume up at about 11 AM, running into one of my reactive loads here, out of the reactive load into the XFX, where I have got some SoundLab ML V30 IRs loaded actually, and just a little bit of delay, a little bit of 2 mono delays, pan left and right, and then from there straight into Logic, which is sitting over here behind me. I have the boost off. I am into the high input here, so it has like a 2204. The amp still has traditional high and low inputs, just like a JCM 800. So the low input, you can get some clean tones out of that. Across on the other side here, this switch here, which is now where one of the the old jacks used to be, that's a front panel switch for the FET boost. So foot switchable, or you can use the switch on the front, and below it is the foot switch jack. So when the foot switch jack is plugged in, the panel switch is disabled. I have got this set in the first clipping mode, so you can run it unclipped, you can run it in the first clipping mode, and then I've got a second clipping mode which is even more compressed. So I've got the gain here only about at 1 PM, right? It's about 6. So you get an idea of the basic sound here. What I'll do is I'll play a chord and I'll bring in the FET boost, and you can just hear what it does in terms of pushing the front end of the amp. Yeah, so I find that FET boost, it just gives it that little kick, right? So great for leads and so on. It doesn't really give you a volume boost, right? It's at the front of the amp. It's a gain boost, but more dynamic, I think, than having like a clean boost pedal on your pedal board out front. Okay, so the amp's now out of clipping mode. There's no Jose diode clipping in the circuit, and what we've got is effectively a hot rodded JCM 800 2204 circuit, obviously with the FET boost front end available as well. So here's our tone with no boost. I've got the gain still at 1 PM on the amp, and everything else is pretty much at midday. I should mention there is a depth pot that's been added to the rear of the amp, and I've got that set at about 11 AM. I'm going to bring the gain up on the front end of the amp here. So let's bring this up to, what is it, about 3 o'clock. I'll bring the boost in. Alright, and if I bring the gain right up, you'll kind of get an idea of how far this thing can go. Again, this is no clipping mode. The gain is on 10 and the boost is off. And I'll bring the boost in. Alright, I'll back that gain back again to 3 o'clock, and what I might do is go to the very hard clipping mode and give you an idea of what that sounds like. Alright, well here we are in the hardest of the clipping mode. This is where we're getting some real 80s metal tones now. Gain is at 3 o'clock still, the amp is dialed in at noon, and as I said, the depth pot on the rear is about 11 AM. There's no boost on, right? So the FET boost is not on the circuit, and here's what our core tone is. And I'll bring the boost in case that's not enough gain. So there we have the core tones. Stick around for the rest of the video if you'd like to see what the mods are, how I made them, and full details of the schematic as well. Happy to share this one. I hope you guys get something out of it. And if you're feeling inclined to warm up the soldering iron and have a go at this yourself, go for it. I will actually post the files on my website like I have with my other mods. So do check the link in the description below. Alright guys, happy modding. I hope you enjoy this one. Cheers, bye. Alright guys, well we'll start with the stock schematic, right? So this is the scheme for the 1987X reissue. It is pretty much a standard 4-hole plexi, right? So the only really changes that they've made here from the original is the addition of this effects loop right here, which they're kind of showing as the effects card It's on a separate PCB. And you can see it runs at a 30 volt supply voltage, which is fed to it from this 47k resistor here, this big 10 watt resistor, which is coming actually from the screen supply of the amp. And W3, W4 sits in between the treble wiper and the input to the phase inverter here. And this is where you'd normally see an effects loop, right? So they've got it in the right spot, but this effects loop, it's terrible, right? So this thing, you put it in and it just tone sucks the amp. I mean, I was warned. My good mate Shia, Monomyth Amps in the US, told me that these things were pretty ordinary, right? And as I was modding the amp, I left it in just kind of bypassed, right? And then when I took it out of bypass, oh my God, a pile of crap. So it came straight out. It's going to be replaced with our high voltage Metro style loop, right? So it'll go in the same spot actually. So we'll come out of the treble wiper in the normal way into the effects loop. From the effects loop, we're going to go into the master volume and then the master volume into the phase inverter input. All right, so here we are. I have marked up the standard 1987X scheme with the mods. Okay, so I'll go through them. There's quite a few to step through here. Bear in mind, okay guys, so what we're going to do is go through the schematic and then we'll get into the pictures. So if you kind of, have trouble orientating yourself around a schematic, no worries, because we'll have a look at how to actually wire these changes into the board itself. So we're just retaining two of the input jacks here. So if you're looking at the front of the amp, it's the leftmost ones, the high treble channel. Okay, that's retained. So high input here, your guitar comes in. So you're going to go through this 33k grid resistor. Again, I'll show you, where these are wired in, right, into the amp itself. This is our Headfirst FET board. It's got a relay on it, right, and this is the foot switchable component of the amp where we're adding in this extra gain stage that is foot switchable. So what we're doing here is when the FET boost is out of the circuit, this is true bypass. So your signal going straight through here, uninterrupted, into V1B. So it's kind of the second side of the V1 preamp tube. This is just like a 2204. This is how they do it, right? It always comes into kind of the other side, or the B side of the V1. And the changes to note here is it's a 2K7 resistor on the cathode. And a 0.68 microfarad or 680 nanofarad. I've just kept that notation stock, but it's the same value, right? 0.68 here, 680 nanofarad is the same thing. I did change this though. I changed it to an electrolytic capacitor. Again, you'll see that in the pics, right? So guitar input through the grid resistor, through the FET boost board into here, and here your guitar signal comes out of this plate here, or through this plate. Here we've changed it. So in the stock amp, this is a 22 nanofarad, right? So you've seen me do this before if you're following the channel. And it's a very common thing with all the builders, right? So in a higher gain preamp, you want to keep the bass under control. So this 22 nanofarad stock in C4, I've replaced it with a 2N2 or a 2.2 nanofarad cap, right, coupling cap. So your signal will pass through here, and it comes into the low input. This is what they do in the JCM 800 or 2204. You use the low input jack to kind of connect the two gain stages. So it comes down here onto the low input jack and connects back through. When there's no jack plugged into here, you get continuity here, and it comes back up. And here I've drawn in the 470 picofarad and 470k resistor onto the preamp gain pot, right? So this is the preamp volume, or the the preamp gain, the gain pot. It's a 1 meg audio taper pot. Now, I didn't draw it on the scheme here, but I did end up putting another 1 meg resistor to ground here. It just reduces the gain a bit, right? So it kind of changes this into a 500k to ground load. And look, you don't need to put that 1 meg on there if you're kind of looking for max gain. Just leave the 1 meg pot there. But if you're trying to keep things a little bit more kind of under control, because there's a lot of gain in this circuit, right? Especially when you put the FET boost board in here. So 1 meg to ground there. You'll see it in the pictures. I've just put it straight on top of the pot. Okay, out of the wiper of the preamp gain pot, straight to the grid of V1A. This is just like a standard 2204 JCM 800. Okay, so straight to here again. So 2K7 cathode resistor here and 0.68 microfarad electrolytic cap to ground. You'll see that in the pictures. And then through this 22 nanofarad coupling cap, this is stock, unchanged, right? Excuse the gap here, that should be connected, right? And this is all stock, the 470 picofarad, 470k, and the 470k. You do need to wire this a little bit differently to get this to go to ground. But what we're seeing here is the standard 2204 JCM 800 setup, right? So 470k, the voltage divider with that 470 picofarad over the top there. Now we're into the third gain stage here. Pretty classic setup here. 820 ohm resistor to ground, unchanged, that's stock. What you will do though is you add this capacitor here. This is like your, often called the fat cap. This is the Eddie Van Halen mod that was made to his Plexi. I've mentioned this before on my channel. He had a much higher value in here, like a 220 microfarad or even a 470 microfarad. If you've got one of those lying around, throw it in there. Anything from like a 22 microfarad here, 63 volts or 100 volts, or a 47, it'll do the trick, right? I went for 47 here just to give it a bit more bottom, but any of those kind of values will be fine. And then this is feeding. This is a cathode follower. This is a classic Marshall setup. So off the cathode follower, what we would normally see is this 100k resistor here. You'd normally connect that, and you can look at this in the stock schematic, right? You normally connect at this point here, which is X, normally connect straight up to the tone stack here, treble, bass, and middle. So what we've done here is implemented some Jose clipping without bringing the master volume in. So the master volume is still over here. We'll get to that. In a really traditional Jose setup, you would actually bring the master volume into this part of the circuit as well. As I mentioned at the beginning of the clip, leaving the master over here, kind of has some other benefits with respect to handling effects loops and just kind of overall control of the power amp, and helps to reduce the noise floor as well. But doing it like this still allows the full kind of Jose experience, right? So credit to the team on Slow Clone, the Slow Clone forum. If you're really keen on getting really into the guts of amp building and technical topics, I fully recommend that forum. There's some really knowledgeable folks on there, and there's a thread on there that kind of has discussed this, right? So I can't claim this as an original masterpiece. So yeah, credit to the Slow Clone guys. This has worked really well actually, and kind of stepping through this, it actually makes a lot of sense. So what we've got is your classic kind of Jose setup here, and we're still driving the tone stack off this cathode follower here, but what we've done, we've inserted this 10k resistor, and I'm using a 0.22 microfarad Wilmer cap here. You can use kind of anything from 0.1 microfarad up to say even 0.47 microfarad. So 0.22 will get you in the right range. And 220k resistor here, you can play with this value anywhere from 150 up to 1 meg. The lower you go, the kind of the more the zeners will have effect. Anything lower than 150 and you'll start to drop too much signal. 220 is pretty sweet, I've found. What I've actually done, I haven't drawn it on the scheme here, but I actually put these on a switch, right? So these two zener diodes here back to back go to ground, and as you'll see in the detailed pictures, what I've actually done here is I've put these on a switch, a little mini switch on the rear of the amp. I've actually, by doing that, I was able to set up two different sets. I've got a 20 volt zener set as driven here, or as drawn here I should say, and also a 5.1 volt zener set. So when in the clip, when I said it went into hard clipping mode, what we were switching to there was the 5.1 zeners. So you can put that on a three-way switch, which is 20 zener on one side, the middle position of the switch, no clipping at all, and the other side of the switch, the 5.1s. If you don't want to do that and you just want to put the clippers in and have them all in full time, then no worries, right? Just wire it up like that. And then from here we're going into the tone stack, and all of this is stock, right? Haven't changed a thing in any of this. From the treble wiper we will go to the effects loop, the new high voltage effects loop. Now if you're not doing an effects loop, all you'll do is you'll run from the treble wiper straight to the input of the master volume pot, okay, which is a 1 meg analog, 1 meg audio pot. But the effects loop will sit in here, or does sit in here between these two, right? Just like it is in the stock amp. So we've got a 1 meg audio taper master volume pot here. Now this is all stock 2204, right? So again, standard JCM 800 has a master volume just like this, where you come off the wiper of the master volume and into the phase inverter input, and everything in here is left unchanged. The only mods we've done to the power amp section of this is in right up here, the depth, right? So coming off the 8 ohm tap here on the output transformer is the negative feedback, okay? So you can see 4, 8 and 16, that's on your impedance selector. Off the 8 ohm tap comes this wire here, and it normally in the stock amp connects straight through this 100k resistor back into the phase inverter. This is V3, the phase inverter here. So what we've done is we've inserted a variable depth pot. It's on the rear of the amp, and it's a 1 meg linear pot with a 4.7 nanofarad cap sitting over the top of it, right? So the value of the capacitor here sets the depth frequency, and where you dial in the pot will give you the amount of depth that you want. So when the depth is on 0, this is completely bypassed and there's no depth at all. And obviously on 10 you're getting maximum effect. Okay, now that is it in terms of the the mods that actually are giving the tone here of this amp. The only other thing that I did was to implement DC elevated heaters. So this is down here. So in the stock amp, these are our 6.3 volt AC heaters here coming off this part of the power transformer. And in the stock amp, these 200 ohm resistors here go straight to ground. This is often called a faux center tap, right? So what I've done is I've removed this from being straight to ground. I've implemented this little voltage divider here. So this is a very common little trick. And what we're doing here is we're tapping the DC voltage off the screen supply. Right, so this is the mains caps here through the choke. On the other side of the choke is the screen supply, and this is this 50 microfarad cap here, one of the big can caps on the top of the amp. I'm tapping off here. This is about 450 volts, give or take. Okay, this line here, DC. And through this voltage divider, a 470k with an 82k, what you end up with here is about 65 volts DC, okay? And this little 10 microfarad, 160 volt electrolytic cap here is just a smoothing cap, right? It's just to make sure that at that point there, you've got the flattest DC signal with no ripple that you could possibly get. And then you set the center tap of the heater supply onto that 65 volt DC reference. This is called elevated heaters. You'll read about this if you don't know about it. DC elevated heaters. Now, it will actually reduce the hum in your amp. And it's a very, very effective method of quite simply, particularly in a higher gain amp where these preamp tubes can be susceptible to picking up hum from your heater supply. This little trick here, well, it's not a new trick, it's an old trick, right? But very effective. So here's the stock amp as I received it before any mods were made. This is, straight up 1987X amp. The only mod that had been made is this post-phase inverter master volume here. So you sometimes see that, always a dual ganged pot, and you can see that this one's been put on the rear of the amp and they've removed one of the additional speaker jacks. So there you go. Now, just in terms of working on the board, you see, as I've shown in this little picture here, you can lift it up. You will need to unsolder a couple of these wires here to get decent access to underneath the board, but I was able to pull out any components that I needed to and resolder new components in from underneath the board. These are only single-sided PCBs, right? So you do need to get underneath them, and I didn't need to pull the whole board out, so don't be too stressed about doing that. And you can see here in this picture, this is kind of sort of a quick snap there, so you can see that disconnected a couple of these cathode and plate wires from V1, even on V2 here, to get enough clearance under the board. And you can see here, actually, I've already started making some changes. In this photo here, I wanted to show that a stock amp is not always a stock amp, right? So this would have been from the factory like this. This is a 27k resistor, right? It should be 2.7k. So that should be a red 2k7. So from the factory, this amp had a 27k resistor sitting in the cathode position here, which is a bit of a shocker to be honest, right? So it would have, in the stock amp, if anyone thought this was a bit, a bit underdone, this would be the reason why. So look, if your Marshall amp is sounding a bit, a bit flat compared to your mate's one, get it looked at. Pretty high chance that something like this has happened. They are not all perfect from the factory. All right, and in reference to the schematic, I will now walk through a collection of photos of the actual changes to the amp. So look at these and then look back at the schematic. Hopefully the two make some sense and join up. This is the high input jack here, this is a low input, okay? And so you would normally, certainly for the gain tones, you're going to plug your guitar into this high input here. This is the grid resistor that's shown on the schematic. It's a 33k resistor, and this is shielded coax here, and it runs through to the FET boost board, which we will show in a second. Okay, these are the two cathode resistors, right? So V1B here and V1A. So both are 2K7 with a 0.68 microfarad. You can see I've got 0.68 50 volt electro caps here. So these are just in parallel. What you can do, right, these PCBs on the Marshalls here, they're screwed in, you can see on these standoffs here. You pull these out, unscrew these bolts. The board will lift up enough for you to get underneath it. You might need to unsolder a couple of these wires here that join onto V1, which I had to do actually just so I could get the nice clearance underneath it. But you can get your soldering iron underneath this board enough to get the stock components out and allow you to solder in the new thing. So don't be afraid, pull these bolts out and lift it up and pull a few of these wires out, don't pull them, but unsolder them, I should say, from the pins on the preamp tubes, all right? And you'll get enough clearance to get underneath here to make the changes you need to make. Okay, this is our FET Boost board. So this is one of our PCBs that you can purchase online. I've got a whole suite of these things now. This is just kind of one of the mod boards that you can use for an existing amp. What's going on here is this is your relay, right, which allows the FET Boost to be foot switchable, and then a bunch of components, resistors, capacitors. It's kind of hidden behind here, but there's the transistor sitting underneath here. It's an LND 150, which is a high voltage MOSFET that will give you very tube-like dynamics. This trim pot here allows you to dial in how much boost. So I've actually got it set just a little bit under half, so it goes the opposite way, right? So if this trim pot was wound all the way around here, the boost would be maximum. So I've got, imagine that's midday there, I've got it just a little bit back. And I just kind of tuned it by ear. High, I mean, you can certainly dial that up, but it gets a bit, it's just almost too much gain, right? It gets pretty full on. All the stuff on this side of the board, this is a bridge rectifier, this is a voltage regulator. This is setting up of a DC voltage from an AC supply that gives you a DC voltage to control the relay. That's all that's for, right? But you got to get a DC voltage in your amp to be able to drive a relay. It's a 5-volt relay, and you'll see in the pictures that I've set up a little auxiliary power transformer to give us a 9-volt AC signal here to enable that to be rectified through the voltage regulator to give me 5 volts DC, and it's driving my relay. Okay. Right, so I'm showing this picture because of this capacitor here. Now, in the stock amp, this is like this grey one. It's a 22 nanofarad. So you can see in the schematic, we changed this capacitor to be a 2.2 nanofarad. I'm using a Wilmer cap here. It's got the exact right pin spacing, so it's slotted straight into the PCB. Okay, to the gain pot. This is my 470k resistor with a 470 picofarad mica cap. It's coming off the low input jack, right? So this bottom lug here, just like a standard 2204, there's no magic here, right? I'm just following the Marshall recipe. Off this lug, off the low input jack, you've got a 470k resistor and a 470 picofarad mica cap. To the gain pot, here's my 1 meg resistor, which I mentioned in the schematic. You can try this with it off or on and just, see what you prefer, right? It'll just reduce the gain a little bit. You don't need to put it on if you don't want it, but I kind of found it was a bit more, a bit more usable there. This is the 820R cathode resistor for the third gain stage. This is my 47 microfarad fat cap. Okay, again I'm using an electrolytic cap, which you want to use here. And that'll give you a nice big thick tone. And here's where things get a little bit interesting. So in the stock amp, this is a 100k resistor here, and this is the cathode resistor on the cathode follower, which, if I just reference the amp here for a second again, it's this guy here, R12. Okay, so let's get back to the picture. So R12 here, there's quite a lot going on. Underneath this heat shrink, I've got a 10k resistor, which is feeding out to the capacitor here. All right, so this black lead here goes underneath and down here and onto this part of, here's my 0.22 microfarad cap. And if you follow the schematic, you'll see on the other side of the cap, we need to get it into the tone stack. This is the entry to the tone stack here. So in the stock amp, there's a yellow wire that's running into this point on the PCB. You pull that out and you wire this guy in here. Also coming underneath this heat shrink is a feed to the cathode itself of V2B. Right, so from the cathode on the pin, the cathode pin on the preamp tube, you're through here into the 100k resistor to ground. Also, that 100k resistor, I've got a 470 picofarad bypass in here. Again, I realised I didn't draw that on the schematic, so my apologies. 470k picofarad from ground to the other side of this 100k. I'll update it, right, in the document that I load up to the website. I'm just literally realised that on the fly. Don't worry about it. This green wire here is going to ground. That's just to shield, that's to provide a shield for the coax, right? Because there's a coax line here that comes out and heads off to the diode clipping mini switch, which again we will show, right? But bear in, just remember, it looks a bit complicated in here, but it just follows the schematic, and I'm using the board as much as possible to house these extra components. Now, the reason I'm showing you this side is because you can see this is the coax that I was just talking about, and I'm bringing this in to this now unused pin here, or unused hole, I should say, onto the PCB. Now, normally what happens is that 100k resistor, which is the cathode resistor for the cathode follower, it goes from here to here. All right, it's as simple as that. It goes from there to there. So you've got to lift one leg of it, pull it out, and then you can insert this additional circuitry. And then you can see I've used a cable tie here just to try and keep these components nice and tight together. But that shielded coax there goes off to the diode clipping mini switch, which is on the rear of the amp, which we will see. Okay, just another view of the same thing. This red wire at the back here, this is the power supply for the FET boost board. Now, I've shown in a separate video completely about how to install our FET boost board. So, if you do these mods, you could do the whole thing without putting the FET boost on the front end, right? You still have, you still have the Jose clipping, you still have selectable clipping methods, and you still have the kind of the core hot rodded 800 feel of the amp. But if you are doing the FET boost, this is where you feed it from, right? So this is what I'm doing here. This is the high voltage supply for the preamp for V1, and so you tap it off there. And down to the power supply end of the board, a few things to point out here. Okay, this is there's a 47k 10 watt big cement resistor here. This is the thing that's providing the 30 volt DC supply for the stock effects loop. So that's come out, right? That effects loop, you just want to pull it out of this amp. It's no good. And what I've got here is the elevated heater setup. So I do have another picture of this that I'll show you, just so you can see kind of how this tag strip is set up. But in terms of wiring it, this is the screen supply here. Right, so this big resistor here that was normally there comes off the screen supply where this yellow wire comes in. So this white wire, I've added this, I'm tapping off this screen supply, it goes under the board and it comes into this side of the tag strip. Here's my 470K, this is an 82K, and here's my 10 microfarad smoothing cap, which is running from the midpoint here to this side. This side is grounded, right? This is the ground. These are the two 100 ohm resistors, which are the faux center tap for the heaters, and here's the heaters here, one side and the other side. Normally, if you're in the stock amp, you'll see a wire that runs straight from here to the ground. So I've cut that wire out, and instead I've got this pink wire here which runs to the midpoint in my elevated heater setup here. So I've chosen these values to give me a voltage here, 65 volts DC, okay? And so the heaters are now running at 65 volt DC elevated off ground, and it does help to reduce the noise or the hum in the amp. Okay, so simple as that. And here's the more detailed view of the tag strip, right? So it's just 3 tags. This is drilled into the PCB. So I took a 3mm drip. And here's a more detailed close-up of the elevated heater setup. Okay, so the tag strip is just drilled through the board. I've got a 3mm drill bit and drilled through the PCB. It took like 1 second to go through this board, and you just bolted it in there. Don't use these holes here. You can see, if you look closely, there's PCB tracks that lead to these holes, and if you use them for this, you'll end up with a high voltage line, because these tracks here are connected to these diodes here, which are your rectification diodes for your high voltage secondaries off the power transformer. Bad idea. Create a new hole, put it over here, and you'll be all good. This is the small power transformer. It's the reason for this is to power the relay for the FET boost. So you can see I've drilled it into the wall of the amp. These are the power switches here for the main amp, right? Normal amp. This little thing here, look, that you can get them from a local electronic supply. I got these from J-Car in Australia. You can get them from any kind of local outlet. I am sure this is like a 9 volt AC, right? So 240 volts in, 9 volt AC center tap. I'm not using the center tap, all right? So that white wire just gets tapped off, but the yellow wires connect through and go all the way to feeding the AC in on my FET boost PCB. And what we're seeing here is the setup for the diode clipping. So on the rear of the amp, I've reused, this is down by the preamp end of the amp. You can see here, this is my FET boost board here, right? And this is my 3-way switch for diode clipping. So the middle position is no diode clipping. Here I've got 2 zener diodes back to back. This is heat shrink over it, right? It's 20 volt zeners on this side, 5.1 zeners on this side, with a 220k resistor to ground. And it's grounded because I'm using that coax that comes from the where the cathode follower is. And here we have the 220k resistor, which is connected to the shielded coax, right? So the signal of the coax goes to this side of the 220, and the shield, which is grounded, it's grounded by that green wire, which I showed, with the, got the cable tie and next to it by the, where the 100k cathode resistor is for the cathode follower. So this is grounded to here. This is how you get the ground to the switch. And finally, this is our depth pot. So this is pretty straightforward, right? So in the stock amp, this purple wire comes straight from the 8 ohm tap. This is the impedance selector here. Okay. The depth pot is sitting in where the second speaker jack would normally be. So here's one speaker jack. There would normally be another speaker jack here. This amp actually had a post-phase inverter master volume in it, in the stock amp that I received to mod. So I pulled that post-phase inverter master out and reused the hole that was sitting there. Rather than putting a speaker jack back into it, I put the depth pot in. So off the 8 ohm tap from the impedance selector, I didn't change that, that's how it is in the stock amp. I cut this purple wire. This purple wire normally runs straight into the board here. Oops. And so I kind of cut it in, what was obviously the right length, and run it into this. This is a 1 meg linear pot with a 4.7 nanofarad film cap, and you can see how I've wired it, right? So in here, bridge those, that goes across, and then into the phase inverter input